Now we get to chapter 3. Chapter 3 is talking about elasticity, in particular demand elasticity, or the full name of it probably the better name would be price elasticity of demand, which tells how much quantity demanded would change given a certain change in the price of a product. Let me show this with a graph, and then we go to the slides. Let's assume you have a demand like this. So here is quantity, here's the price, and that is your demand line or demand curve. Now this would tell me, for example, if price is at P1, quantity demanded is Q1. If price goes to P2, quantity demanded will go to Q2. So price drops, quantity demanded goes up a huge amount. So a little bit of change in price would cause quantity demanded to go up a great deal. Let's compare that situation with this one. Here is quantity. And here's your demand. Price, again, let's say price is P1, quantity is Q1, we half the price to P2, quantity demanded will go to Q2. So a big drop in the price would cause a little bit of change in the quantity. The reason for that, of course, since you're looking at the linear demand curve, the reason for that is the slope of the line. But the slope is one story, which is part of the elasticity also. So it would show that depending on how your relationship between the price and quantity demanded is, a certain percentage change in the price would cause more or less percentage change in the quantity demanded. So based on that, we can come up with a formula and say that elasticity, demand elasticity, if you will, equals percentage change in quantity demanded over percentage change in price of the product. Okay? So for example, if price goes down by 10%, if price goes down by 10%, what would happen to quantity demanded? Okay? One thing would be quantity demanded can go down also by 10%, or quantity demanded can go, quantity demanded will go up. Let's get rid of that. Quantity demanded will go up also by 10%, or quantity demanded will go up by less than 10%, or quantity demanded will go up by more than 10%. So if, let's say in particular price goes down by 10%, quantity demanded goes up by 20%. Therefore, according to the formula, in that case, elasticity of demand would be equal to percentage change in quantity demanded, which is 20%, over percentage change in price, which is 10%, which would be equal to 2. By the way, since it is reduction in the price of the product cause an increase in the quantity demanded. In other words, they are doing it in two different directions. The numerator would be positive, the denominator would be negative. Therefore, elasticity would be negative 2 instead of positive 2. If of course price, another scenario, if price go down by 10%, then quantity demanded goes up by only 5%. In that case, the elasticity would be equal to 5% divided by minus 10%, which would be equal to minus 1/2. Continuing on the same thing, if price goes down by 10%, quantity demanded goes up also by 10%, then the elasticity would be equal to 10% in change in quantity demanded divided by minus 10% change in price, which would be equal to minus 1. So those are different scenarios that can happen. Now, if elasticity is equal to, let's look at the absolute value of elasticity. If the absolute value of elasticity is equal to 1, right, instead of negative 1, we say 1, then demand is unit elastic. That means 5% change in price would bring about 5% change in quantity demanded. If absolute value of elasticity is greater than 1, then you say demand is elastic, right? And finally, if elasticity you calculated is less than 1, you say demand is inelastic. Okay? So elastic means it is very responsive to a price change. Inelastic means it is not responsive to a price change. So we're going to explore those things by looking at the slides we have. Okay, we go to elasticity, chapter 3. Okay, the first slide is saying, why should managers study elasticity, right? Again, the important thing is to understand, as far as the price elasticity is concerned, how do your consumers react to any price change that you're about to offer? And the case at the beginning of this chapter with Procter & Gamble would show that. Because depending on the elasticity, if you reduce the price, your profit might go up or it might go down, depending on the elasticity. So that is very important to understand the elasticity of demand for your product, or the price elasticity of demand for your product. Another forms of elasticity which would be studied in this chapter is the income elasticity. Income elasticity is the response that consumers would have to any change in income. So if their income goes up by 10%, what would that do to their demand for your product? Would that increase the demand for your product by 10%? Would it increase it by less than 10%? Would it increase it by more than 10%? Again, it depends on the type of product we are talking about. We will discuss this in the chapter. Another issue in this chapter is talking about cross-price elasticity. Cross-price elasticity, which shows the impact of price change of your competitors. Price change of your competitors on the demand for your product. So if your competitor dropped the price, what would happen to demand for your product? Or you can imagine if your product, the two products from your competitor and you are very close substitute for each other, once they drop the price, everybody would switch from your product to theirs. Therefore, demand for your product would fall greatly. However, if your product is unique, or kind of unique, when they drop the price, consumers are not going to escape from you. They're not going to run away from you because your price is now relatively higher than their competition. So those are very important to know. So we start with the elasticity or the demand elasticity or the price elasticity of demand. It says demand elasticity is the responsiveness of quantity demanded to changes in the factors that influence the demand, such as product price, income, and the price of related goods. Okay, so those are the three things we're gonna talk about. So number one, we start with the price elasticity. In general, elasticity, this is like the formula I had. Hold on a second. This is the formula I had on the piece of paper at the beginning. Elasticity, let me rewrite this. Elasticity, or EP, equals percentage change in Q divided by percentage change in price. So these are basically the same thing, right? A relative change in the price, what would that do to the quantity demanded for your product? Okay? On a straight line demand curve like this one, the percentage change in price would be shown vertically. From P1 to P2, price drops and quantity goes up. This percentage would be important. Now, how do you calculate the percentage? Let me see. I think I need to go back and do it here. So we say the price elasticity is equal to percentage change in quantity divided by percentage change in price. How do you figure out the percentage change in quantity? Well, that is change in quantity over quantity divided by change in price over price. Therefore, EP would be equal to change in quantity over change in price multiplied by price divided by quantity. This would be the formula for price elasticity of demand. You would notice, of course, that this first part is the slope of demand curve. Well, actually the inverse of slope of the demand curve, right? Because the slope is rise over run. Slope is change in P over change in Q. And multiplied by P over Q, so it depends on whether the P is higher than Q. So if you're up here on the demand curve, your price is high, here's the price, and Q is low. If you go down in your demand curve, somewhere about here, price is lower and quantity is higher. So when the price is lower and quantity is higher, this would be smaller. Okay? So the elasticity has to do with the slope of the demand curve and also where you are on the demand curve. If you're on the upper part of the demand curve, then P over Q would be larger, therefore elasticity would be larger. If you're at the bottom of the demand curve, the P over Q would be smaller, therefore the elasticity would be smaller, given the same slope in both cases. Now here are some examples, real examples of the elasticity. Again, you will see, by the way, all of them are negative. The reason for all these elasticities to be negative is because demand is downward sloping. So elasticity for cereal is minus 0.55. Elasticity for fish is minus 0.29. Elasticity for Newman's Own pasta sauce is 2.32. For orange juice is 1.39. So here you have inelastic demand for cereal and for fish, and for the sauce, pasta sauce and orange juice, you're dealing with elastic demand. That means it is more responsive to price changes. For these two, Newman's Own pasta sauce and orange juice, they're more responsive to price changes than fish would be or cereal. So what does that elasticity do to your revenue? This table will show the impact on the revenue when the demand is elastic and when the demand is inelastic and unitary elastic. So we start with this case where the absolute value of elasticity is greater than 1. That means demand is elastic. When the demand is elastic, that means the numerator, again, recall that the elasticity is percentage change in Q over percentage change in price, right? This is the elasticity. So when this is greater than 1, that means the numerator here is greater than the denominator. So percentage change in QD is greater than percentage change in price, okay? So a little bit of change in price will bring about a big change in quantity demanded. So price increase results in lower revenue, and price decrease results in higher revenue because of the impact it would have on QD. So if demand is elastic, right, by lowering your price a certain percentage, your revenue will go up. One more time, if demand is elastic, when you lower your price, your revenue will go up. On the other hand, if demand is inelastic, the opposite would happen. If demand is inelastic, that means in your formula, the numerator would be smaller than denominator. The percentage change in quantity would be less than the percentage change in price. Therefore, in that case, when you lower your price, your revenue would also be lowered. When the price decreases, lower revenue would result. If you increase your price, your revenue would also go up. So they move in the same direction when it is inelastic. And finally, in special case, when you're dealing with elasticity equal to 1, which is unitary elastic, in that case, the numerator in this formula, the numerator and denominator would be equal to each other. That's why you come up with 1. And in that case, fluctuation in price, whether you increase the price or reduce the price, does not impact your revenue. So you see, it is important to know whether the demand for your product is elastic, inelastic, or unitary elastic. And knowing that would help you set your prices. Should you increase your price? Should you reduce your price? What should you do to capture more customer, to entice people to come and buy from you instead of buying from your competitors, right? And what would happen to your revenue is very important, because that's how you look at your profit, right? If your revenue go up, assuming the same cost, when your revenue goes up, your profit would be higher. Therefore, you would be doing much better. In this picture, you have two panel. One shows elastic and the other one shows inelastic demand. If you look at the left panel, it shows demand is elastic, right? Again, when you look at the upper portion of any demand curve, but here the demand is drawn kind of flat, also the slope. Therefore, when you move from P1 to P2, this much reduction in price move you from point A to point B. That means Q1 goes to Q2. So in a sense, what is happening is, if you want to calculate your revenue at point P1, it would be P1 multiplied by Q1, which would give you this whole rectangular from O to P1 to A to Q1. When you lower your price to P2, now P2 multiplied by Q2 would give you O P2 B Q2. So by moving the price from P1 to P2, you would give up Y, you would give up this area, this much of your revenue. However, you would gain X. So your gain is much more than your loss because of lowering prices. Therefore, your revenue will go up. Again, your revenue is going up because demand is what? Demand is elastic. On the right hand side panel is showing demand being inelastic. Demand being inelastic. Again, at the lower part of the demand curve, you would see that the prices drop from P1 to P2. You go from Q1 to Q2. Again, when you lower the price from P1 to P2, what you're losing out of your revenue in this area on the graph, what you're gaining is this area on the graph. You lose the blue part and you're gaining the green part. Again, what you're losing in this case is more than what you're gaining. That would be your revenue. Therefore, when price goes down, total revenue would also go down because it is inelastic. By the way, on the left-hand side panel, which is the same, price is going down, your total revenue went up because your gain is X, your loss is only Y. So this is a graphic representation of what happened when you lower the price. Next, the question is, what impact the elasticity? What are the determinants of price elasticity for your product? Of course, the most important variable is the number of substitutes available. The number of substitutes available to the consumers. So you can imagine, the more substitute available, the stronger the competition by your competitors, the stronger the competition, the more elastic the demand would be. Okay? That means basically if you increase the price, you're going to lose a lot of revenue because everybody will go to your competitors, right? So the number of substitute good is important. Another question is the percentage of consumers' income that is spent on the product, right? The best example I can think of is salt, right? Salt is very cheap. It doesn't take that much of your income to buy a can of salt, or what, $1? And that can of salt would last you 6 months. So if tomorrow the price instead of $1 becomes $2, they double the price, right? Is that gonna impact your demand for salt? Not really. You still buy the salt, right? Because the difference between $1 and $2 every 6 months, it really does not change anything for you. Therefore, in that case, in case of demand for salt, demand would be very inelastic. That means it is not responsive to a price change. Again, you can think, if price of salt goes down from $1 to 50 cents, what are you gonna do? Are you gonna double your consumption of salt? Not really. There is nothing in there for you. So you would stay with the same quantity no matter what the price is. So demand is basically kind of vertical. It is not responsive to any price change. Thirdly, the time period under consideration. The time period under consideration would change the elasticity. So think of the gas prices. Think of the gas prices. If gas prices go up today, all of a sudden double, what can you do in the immediate short run? Not a whole lot. You still have to go to work, you still have to go to school, you still have to, the same habit, you cannot change your car, you cannot do anything in the short run, right? So in the short run, demand for gasoline is very inelastic. That means it's not responsive to any price changes. So double the price, you might cut your driving a little bit. But if the price stays up or keep going up, within a year or two, when it's time for you to buy a newer car, right? This time you're gonna go with a more efficient car. Get a hybrid, get an electric car, right? Because you don't wanna spend a lot of money on gasoline. Or you would carpool. It takes some time to make the adjustment for carpool. Or you would learn how to ride your bike to go to school or go to work. So given time, demand becomes more elastic. Demand becomes more elastic. Inelastic is when you don't have a choice. You have to buy the product, right? In the short run, you have to buy the product. In the long run, this demand slowly becomes flatter. It would become more elastic because you find alternative. You find alternative fuel. You find alternative ways of commuting. The two extreme cases are shown in this panel. One is a perfectly elastic demand curve, the other one a perfectly inelastic demand curve. So perfectly elastic demand curve says, okay, price is here. At this price, I'm gonna buy any quantity, right? There is nothing. Now, if price goes up above this P, I'm not gonna buy anything. Done. On the right-hand side, you have inelastic, a perfectly inelastic demand curve. Let's assume there is a medicine you have to have. right? It doesn't make any difference how much the medicine is. If there is no alternative, if there is no substitute for the medicine, and you have to have it to stay alive, you would pay for it, no matter how much it is. So if the price is P1, your quantity demanded is Q1. If price doubles to P2, you still demand Q1, right? And triple, you still demand, right? So you need one shot of this medicine or one pill a day, so you buy it, right? That would be an example of perfectly inelastic demand curve, again, for a product which does not have any substitute at all. You have to have it. We extend this concept of elasticity to income elasticity also. So in this case, you have income elasticity EI defined as percentage change in Q over percentage change in income. So it says if your income goes up by 5%, what would happen to your demand for automobile, for example? We are talking about automobile industry. What would happen to your demand for automobile? Does your demand for automobile go up also by 5%? Does it go up by more than 5%? Does it go up by less than 5%? That would be the income elasticity, the degree of responsiveness to change in income and its impact on your demand. That is income elasticity. Again, in that, you're talking about normal goods, right? A normal goods, assuming automobile is a normal good. And so normally, if you're talking about normal good, when income goes up, you buy more of it. When income goes down, you buy less of it, right? So here are some example for cream, for apples, for potatoes, right? Now, one thing you would notice is all of them are positive because we are saying all of them are normal good. Again, normal good is defined of what happened to quantity demanded when income goes up. If income goes up, quantity demanded go up, then you're dealing with the normal good, right? But they have different elasticity. For cream, it is 1.72, very elastic. For apples, it is 1.32, also very elastic. For potatoes, is 0.15, right? Inelastic, right? So you can imagine if your income goes up, you're not gonna consume a whole lot more potatoes. It's not so exciting that you go out and eat potato every night. We also have what is called inferior good. The way we see inferior good is that if income goes up, demand for that good would go down. So if we have a product for which over time we have seen when the income of the people go up, their demand for it will go down. They move in the opposite direction. Then that good would be called an inferior good. Okay? So income of the people go up, right? They demand less of it. I give you an example. If income of people go up, if we are in a period of prosperity, if things are better, people would buy less of the no-name brands or less of the store brands. And then they go up buy more of the name brand product, right? So store brand or no-name brand would become inferior good. In this example, actually, it is showing the chicken to be the chicken calculated. I'm sure they have calculated correctly. The chicken is an inferior good. I assume pork would also be an inferior good. Again, you're comparing it with beef, right, and lamb. When income goes up, people would buy more steak, people would buy more beef, according to this picture we have here. So chicken considered an inferior good. Another concept of elasticity applied to cross-price elasticity. Cross-price elasticity. Now that one is shown here as elasticity of X, product X, as it relates to product Y. And that is equal to, here we have to use X and Y because we are dealing with two different products. Percentage change in quantity of X that results from a percentage change in the price of Y. Okay? So we are dealing with two different products. So for example, what happened to quantity demanded for Pepsi-Cola? If price of Coca-Cola go up, if price of Coca-Cola go up, what would happen to demand for Pepsi-Cola? Well, if we are assuming that Coca-Cola and Pepsi-Cola are substitutes for each other, when the price of one goes up, people would switch from that to the competition to go to the other product. So price of Coca-Cola go up, demand for Pepsi-Cola will go up. Okay? So they move in the same direction. So in this case, in the denominator, if PY goes up, and QX also go up, they move in the same direction, then this cross-price elasticity would be equal to what? To a positive value. So you would conclude that if the price elasticity, cross-price elasticity, EXY, is positive, you're dealing with what? Substitute good. The two goods are substitute for each other, right? The higher the value, the positive value, the higher the positive value, the closer of substitute these products are to each other. Okay? Now, then let's think of steak sauce and steak. If price of steak go up, what happens to demand for steak sauce? If price of steak go up, what happens to demand for steak sauce? There's less steak people are eating, therefore they would need less steak sauce. So when the price of steak goes up, demand for steak sauce will go down. So they move in the opposite direction. Therefore, this cross-price elasticity, this EXY would be what? Would be negative. So if that is negative, that means the two products are what? Complementary product. Okay? Therefore, depending on the sign of the cross-price elasticity, you can tell whether the two products are substitute for one another or they complement one another. And of course, you can conclude also if the cross-price elasticity is equal to 0, so price of one product goes up, nothing happens to quantity demanded for the other one, that means the two products are not related at all. So you can figure out whether the products are substitute or complementary or not related at all. And the magnitude would also tell you the strength of the relationship between the two products. So here is example. Again, it says two goods with a positive cross-price elasticity, right, said to be substitute for one another. The example is given to you as boilers, chicken and beef, a positive cross-price elasticity. Chicken and pork, also positive, right? So these are substitute for one another. because the cross-price elasticity end up being positive for them when we calculate them. That means when the price of one goes up, the quantity demanded for the other one would go up. Here is complements to when they are negative, when the cross-price elasticity is negative, right? That means the two products are complement for another. Here they calculated the cross-price elasticity between bread and eggs, and they come up with this. So to be not a very good example, bread and eggs. Actually, the value is very small, very close to zero. I mean, it's negative, but it is a very small negative number. So I really think that since the magnitude is small, the elasticity is small, they are probably not related to each other. But the book likes to call them complementary goods. Couldn't find a better example. Now, there are some technical and more algebra and calculus examples in the appendix of this chapter, which we are not going to get into. But if you are so inclined, you can read it, and if you have any questions, I would be more than happy to answer you.